welcome to this video tutorial here involving probability and conditional probability. We are going to work through the items seen on the screen. Perhaps you want to hit pause before we try this out together. So when we're trying to solve this problem, we are needing to find 5 items, and really to find probability of x and y, we are going to need to utilize our conditional probability formula, working with the probability of x given y. So over here on the side, we're going to start off by noting that the probability of x given y is the probability of x intersect y, or x and y, divided by the probability of y. Remember, we always divide by the probability of what we know is true, because that's the total outcomes we're considering. Now as we plug in here, we know the probability of x given y is 0.18. We don't know the probability of x and y, but we know that the probability of y is 0.75. To solve for the probability of x and y, we're going to multiply both sides by 0.75. And when we type that in our calculator, 0.75 times 0.18, we get 0.135. Remember, with probability, we ask to show at least 3 decimal places correctly rounded. In situations where the decimal just terminates and stops, ideally we could show all of those decimal places. So probability of x and y is 0.135. Now continuing, we want the probability of x or y, which is the probability of x union y. Our handy dandy formula tells us that that is the probability of x plus the probability of y minus the probability of x and y. So we're going to, the probability of x or y is equal to the probability of x, which is 0.245, plus the probability of y, which is 0.75, minus the probability of x and y, which we already found is 0.135. So again, we will just turn our attention to our calculator here, plug these things in, and give at least 3 decimal places correctly rounded if applicable. Although we do keep all of the decimal places on our calculator if the decimal continues for quite some time. So when I'm typing that in, I'm getting 0.86 for the probability of x or y. We'll put that over here, 0.86. Now for the probability of x complement, it's just 1 minus the probability of x. Basically, the complement of x, with the bar on top, means everything except x. So 1 is a perfect probability. That's like 100%. If we subtract away the probability that x happens, we get the probability that x does not happen. So this is going to be 1 minus the 0.245 that we were given up above. And when we take 0.245 away from 1, we get 0.755. And that would be the answer for the probability of the complement of x. For the probability of the complement of y, similar idea. It's going to be 1 minus the probability of y. Up here, the probability of y is 0.75, so we'll take away 0.75 from 1, and that's going to be a 0.25. It doesn't really matter to me if we write the 0 before the decimal point or if we don't. Either way, generally speaking, is okay. Unless I were to specify otherwise, either of those would be fine. And last but not least, the probability of y given x is the probability of y and x divided by the probability of x. Remember, we always divide by the given probability. Probability of y and x is the same as the probability of x and y. The order of those letters does not matter. So that'll be 0.135. Probability of x from up above is 0.245. And we're going to take those two numbers and divide them. 0.135 divided by 0.245 comes out to be 0.55102. At least 3 decimal places correctly rounded, we would go with 0.551. So really, probability isn't bad. We just have to know the notation. We have to know our key formulas, and ultimately there will be 5 of them. And then we work with those formulas, we work with our notation, and we come up with the results that we need.